All right, let's do our little video on significant figures. This is how we tell whether or not certain numbers in a measurement matter or not. It basically helps us decide the precision of different measurements that we will make. So the significance of this, I probably have to select the actual writing tool here. So we'll do significant figures, or sig figs, or significant numbers. They're often called, just depends who you're talking to. Right here we'll call them sig figs. There are four basic rules for this. The first rule is that any non-zero number is significant. So any number that's not zero is significant. Okay? Our second rule is that any zeros that are between non-zero numbers are significant. So any zeros, don't think they're supposed to be an E there. One moment. Sorry. Any zeros between non-zero, is that right? Non-zero numbers are significant. The third rule is that zeros to the left of non-zero digits are never significant. So zeros to the left of non-zero numbers are not significant. Our third rule, or fourth rule, is that zeros to the right of a decimal and preceded by non-zero digits are significant. And we'll go back in a minute and do some examples of each of these. Zeros to the right of a decimal preceded by non-zero numbers are significant. And then the last rule we have here, our fifth rule, is that when a decimal is not present, zeros to the right are not significant unless otherwise stated. So if no decimal then zeros to the right are, again, not significant. Okay? And so those are the five basic rules. You kind of have to do your best with them, see how you do with them, but we'll do a few examples here right next to these numbers just so you can see. For example here, any non-zero numbers, if I look at a number like 365, the number of days in most years, would have three significant figures there, and that would be that. You could have another number, 26.2, that would also have three significant figures. Down here, any numbers with any significant numbers here with zeros in between, that's going to do it for it. So we could have 102 would also be three significant figures because we would count that. If we went to 1,002, that would then have 4 significant figures. Zeros to the left of non-zero numbers are not significant. So if I had a number such as 0.005, this would have 1 significant figure because these are to the left and there's no other significant figure on this left side, so that rule number 2 doesn't come into play, and it would just be the 1 significant figure. Here, zeros to the right of the decimal place preceded by non-zero numbers are significant. So for example, I could have something like 20.0. Here I have a significant digit, I have a decimal, so rule number 5 doesn't play in, and then this is written after, and this counts as significant because if it wasn't significant, I wouldn't have written it. I would have just written 20 and not put a 0.0. So there's a reason I put it there, and that is that I have measured it to this precision. So anything like that after, this would be 3 significant figures. If I had another 0, it would then be 4 significant figures, and so on and so forth. If I put any other numbers out in front here, then of course I would count them as well. And then here, if there is no decimal, then zeros to the right are not significant. So we can go with that same example, 20. This would have 1 significant figure unless it was otherwise noted. Sometimes people note this by putting a bar above it to say that was also significant. Sometimes people note this by putting a decimal there, in which case this rule then doesn't apply and you're back to here where there's a decimal, and they would be basically telling you there are 2 significant figures because otherwise they wouldn't have written the decimal, and that's probably done a lot commonly, but this helps in case it's a number more like 200 and it's only 2 significant figures instead of 3. If I had to put a decimal there, then it would be saying 3 significant figures. So if there's no markings or indications, then rule number 5 basically states that you assume the least precision that you actually can, just to be on the safe side. It's better to be err on the side of caution, I guess, than to assume that this is than assume something is significant that is not. When you don't want to pretend you have more precision than you really do. To sum these all up, the basic thing I really do to look at these is I simply look for the first and the last significant figures. I use these rules to find them, and then you count those numbers, those 2 numbers, and all the numbers in between, and you're pretty much good. So ultimately I use these rules to decide whether a number is significant, and then just and find the first significant figure and the last one, and then count all in between. So if I had a number like 126,000.05, I would look at this and say, this is my first significant, this is my last significant, and then I would just count all from the first to the last, which would be 3, 6, 7, 8 in this case. If I looked at a number like 0.0 or 0.05802, I would look and say, all right, this is my last significant number, this is my first significant number. I would count them, and there would be 4. So 1, 2, 3, 4. Hopefully this clears stuff up, and we'll be good to go.